In this lecture, we're going to talk more about the sun's amplitude and the fact that it doesn't change evenly throughout each season. As you've learned in an earlier lecture, the sun's amplitude is 0 on either equinox, and it's at its maximum on either solstice. Each year, the direction of sunrise and sunset veers with the seasons. In the northern hemisphere, the sun rises and sets north of east and west in the spring and summer, and south of east and west in the fall and winter. And of course, it does just the opposite in the southern hemisphere. Now, this seasonal veering I'm talking about doesn't take place evenly throughout the season. The sun's amplitude remains near its maximum around the time of the solstices longer than it remains near 0 around the time of the equinoxes. What this means is that the direction of sunrise and sunset changes relatively slowly in the days just before or after either solstice, but changes relatively quickly in the days just before or after either equinox. So if you come here to the equinox, right here, in the days following the equinox, the amplitude changes very fast. And as you get on out toward the solstice, the amplitude change slows way down, and it slows down. And then on the way back, it moves slowly until you get closer to the equinox and it speeds up again. And then going the other way, it's going fast. Gets out here near the solstice, and it moves slow, and slow, coming back, and it moves very fast as it approaches or relatively fast as it approaches the equinox. So when we're going to be using this information to help us determine the approximate direction of sunrise and sunset, but if we know the uneven nature of the changes in amplitude, that will help us do so with greater accuracy. Let's look now at a specific example of the nature of amplitude changes. We'll say we're here at 30 degrees north latitude, where the maximum amplitude is 27 degrees. So on the September equinox, the sun rose at 90 degrees and it set at 270 degrees. But 14 days later, the amplitude is already 7 degrees south, which means the sun rose 7 degrees to the south of east, or 97 degrees, and set 7 degrees to the south of west, which is 263 degrees. Now let's fast forward through that season, and we come up to 14 days before the December solstice. At this point, the amplitude is already 26 degrees south, which means the amplitude is already approaching its maximum. So 26 degrees south of 90 degrees means the sun rose today at 116 degrees, and it set 26 degrees south of west, which means it's set at 244 degrees. And then in the next 14 days, the direction of sunrise and sunset only changes 1 degree as the amplitude reaches its maximum on the solstice. So this example here will show you that the amplitude changes much faster near each equinox than it does near each solstice. At this point, you might be thinking, this stuff is getting incredibly complicated, but it's really not. What you want to hold on to at this point is the fact that the direction of sunrise and sunset drifts throughout the seasons. The extent of that drift is defined by its maximum amplitude, and that the amplitude changes throughout the season don't take place evenly, but take place more rapidly near the equinoxes than they do near the solstices. That's the central point of this lecture. So now let's move on to another lecture and learn some other stuff.